Think back to 2017. How would you handle secret information in the AWS cloud? How would you make sure that your secrets stay secret without the tools that you have access to today? Well, in this Retro Reacts, we're going to see how IDT solved this problem back in 2017.
Welcome to This Is My Architecture. Today I'm joined by Nathaniel from IDT. Welcome, Nathaniel.
Thanks.
What does IDT do?
We deal with international telecommunications and services.
Cool. Now
Okay, so this is an international telco. So let's see how they're handling secret information within their AWS cloud builds.
you guys build lots of different systems and you have an issue or a challenge about changing something. Tell us about it.
Yeah, so we actually had recently a scenario where the BI team came to us and said they wanted to change a product's key value mapping for our application.
Which doesn't tell us much, but okay, so the business intelligence team said, hey, we want to make this change, and then what happened?
Existing infrastructure, that would have been a real crawl and run to be able to change all of the apps
It's
and
a nightmare
the configurations.
last minute thing, isn't it?
Right. So
Okay, so in their existing infrastructure, they have a whole bunch of hard-coded values is what I'm taking from that?
we actually came up with a solution that integrates very well with our ECS environment. So what we're able to do is we're using Console, which is a HashiCorp configuration management service, which allows us to store our configuration management as a keep value pair.
Okay, so instead of hard coding this stuff or using whatever system they were before, which they haven't mentioned, they're leveraging, which was at this time, the relatively new HashiCorp Console, C-O-N-S-U-L, so console, I guess, service to have centralized configurations.
But we're also doing it in a secure way. So what we're actually doing is a user might say, I want to make a configuration management change, like in this case, the product value.
Yeah.
So what the first
Again, I don't know how product value is a configuration change, but whatever, this is the challenge of these videos is that you don't get the whole architecture question. You hope that the Q&A gets to the specific points so that we can learn something.
service we're using is he's making the change and it's going encrypted through KMS and storing the key value mapping file on S3.
So to be clear, it doesn't encrypt in KMS. You get the key material from KMS, the key management system. You can encrypt it and then into S3. Now, this was 2017, so the integration wasn't as slick. But basically what that means is you're managing your own keys and who can access them when and where for data that's stored in S3.
We have it for backup, or if at any given time someone wants to be able to see what the current state of the file is.
But it's completely secure and
Completely
encrypted.
secure and encrypted. And then after that point, once that's successful, the user's request is then mapped through the ELB to the console server. And the great thing about console is that it's in constant communication with the client, which in this case is living on the ECS cluster where the app is living.
Okay, so he stored it, his configuration item in S3, encrypted with a KMS key, and now he's going through console to ask the server to do something with it. Let's figure out what.
Because the app is actually wrapped in a wrapper called env console, which is another HashiCorp product, which allows the app to instantly know about a change from the environment variable and be able to restart the app within 1 second. So it's
Okay, so basically he's using the console services from HashiCorp and to send an update and to tell the application like, hey, you've been updated, make a change.
instantaneous.
So when you're saying instant, you mean for all intents and purposes,
real
it's
fast.
like bang, it's made a change. So the person's made the change up there, it's already inside the container.
Yeah, and like I mentioned earlier, if, say, for example, at any given time, the user wants to be able to know what the current configuration is, all he's going to do is do the same thing, but reverse. He's going to make a request to S3, and then that S3 is going to be decrypted through KMS, and then he's going to be able to have that plain text file locally.
Okay, so the interesting thing here is that they're not re-rolling the containers, they're not reinstantiating them, they're actually making changes to the container environment, which is a choice. You can absolutely do that, but a lot of teams prefer to have an immutable container environment, make the change somewhere else. But let's keep listening.
Provided visibility that's, of course, secured through IAM and credentials, but they can still see what the values are when they need to do maintenance, verification, checking, all that other good stuff.
Yeah, and like I said, it's also great because you have a backup in case of any DR or anything else that happens for the environment.
If you need to restart, you're just grabbing the last known state and you're good to go.
Yeah.
And that's a good point, is that the state is stored in this configuration object in S3. It's secure. You've got the to be able to dictate access through KMS. So this is an interesting solution. Now, this was way back in 2017. So what would we do differently here? Well, first of all, configuration information, you need to figure out whether that's actual secret or not. So this is billed as, updating secrets. It's not really secret. So there's an AWS Secrets Manager service for secret information. This is just a good practice to encrypt your configuration information. Now, there could be secrets in there, or it could just be the normal sort of configuration items. Now, there's a whole host of other options. Most customers at this point are going to be leveraging Kubernetes to manage their container environment, and Kubernetes has the idea of a secret store, as well as the idea of configurations for your pods within it itself. Now, the secrets system within Kubernetes needs actually an encryption implementation, which you can do with managed K8s in AWS and KMS and a few other services behind the scene. So conceptually, this architecture is pretty solid. However, you could strip out the HashiCorp systems. You could leverage probably what you're already leveraging for the rest of it, which is Kubernetes or K8s. And then you could use AWS Secrets Manager where appropriate. S3 is an amazing, solid place to store things. You might want to be storing your configuration items depending on the access. You may want to drop them in Dynamo, and you can encrypt them with KMS in Dynamo. But S3 is solid. It's got a high enough performance, and the durability can't be beat for the cost. So you may actually not change that much through this, but I would strongly recommend that you always determine what's actually a secret versus what's just good practice to encrypt the data. You should be encrypting things. It's super easy to do that in AWS, and it gives you an additional layer of protection and control to make sure who's accessing your information. But AWS Secrets Manager is an amazing tool to actually logically separate true secrets and control their access separate than configuration items. And that's a really important part, because different systems and people are going to need access to config than the actual secrets. So you want to keep that separate. Other than that, conceptually pretty solid. Not much that you would change other than updating the services. When possible, you want to leverage those native AWS services, because you get the extension of IAM as opposed to trying to balance users between two products. And that's how you would change that architecture from 2017. Remember, a lot has changed over the last few years. We have way more options, way more customized tooling available in the AWS cloud. And with that, we'll see you in the next one.